Next, we come to the Pythagorean Theorem, a very important use of this work with quadratic equations. Now, it's important when we define the quadratic formula that we have at least implicitly a triangle in our heads. We need to make sure we know what we mean by our A's, B's, and C's. The Pythagorean Theorem gives us that if we have a right triangle with legs A and B and hypotenuse C, then the length A squared plus B squared equals C squared. All right. It's important to know where this equation comes from. Generally speaking, I don't accept this as the definition of the Pythagorean Theorem without at least a verbal recognition of where those letters come from. So then, making use of the Pythagorean Theorem, we can find an unknown side of a right triangle. I'm going to name this so that I have a letter to work with. All right, that's 5 squared plus 12 squared equals C squared. Again, the length of one leg squared plus the length of another leg squared equals the square of the hypotenuse. And in this circumstance, we don't need to talk about the principal square root or anything like that, since, of course, we're looking at lengths, and there's no such thing as a negative length. All right, let's give it a name, and we'll find a missing leg this time. So applying the Pythagorean theorem, we get one leg squared plus the other leg squared equals the hypotenuse squared. So we have 9 plus b squared equals 25. Equals 4. It's important to note, of course, that the Pythagorean theorem holds with our precise definition, talking about these legs and hypotenuse, regardless of how the triangle is oriented, right? So while this has been turned on its side and we have our hypotenuse on the bottom, this is still our leg, a leg that we're searching for, right? So let's name it and apply the Pythagorean theorem. So a squared plus 8 squared equals 10 squared. And solve as usual. There we have it. And of course, we realize that they're not always going to come out nicely. We're not always going to have a perfect Pythagorean triple. So say, for instance, we have 2 squared plus 3 squared equals our beam C. And there's the precise answer. Of course, we can quickly get a decimal approximation.